Hello friends, we are going to discuss concept of differentiation and integration from calculus of A-level syllabus, and I have taken a problem from A-level past paper. Now the problem here is the diagram shows the curve y equals to x power 3 ln x for x greater than 0 and its minimum point m. A. Find the exact coordinates of M. B. Find the exact area of the shaded region bounded by the curve, the x-axis and the line x equals to 1 upon 2. So now we will start the solution. In A part, we have to find the exact coordinates of the point M. Now in the figure M, it is already mentioned that this is your minimum point. It means that the M point would be the stationary point. Therefore, first we will have to find out dy by dx. So we will apply here product rule, x cube into 1 upon x plus 3x square into ln x. Now we will simplify this, so it would be x square 1 plus 3 ln x. Since M is stationary point, hence dy by dx equals to 0. So 0 equals to x square 1 plus 3 ln x. So you can write here x square equals to 0. So x equals to 0, and the another one is 1 plus 3 ln x equals to 0. So we can write here ln x equals to minus 1 upon 3, and therefore x equals to e raised to the power minus 1 upon 3. We can also write this 1 upon cube root of e. Now x equals to 0 we cannot consider because this is out of domain, so we will be considering this point. Now we will substitute the value of x in the main equation, and the main equation here is y equals to x cube ln x. So when you substitute here the value e raised to the power minus 1 upon 3 whole power 3 ln e raised to the power minus 1 upon 3. So we will simplify this. Here 3 and 3 get cancelled, and e power minus 1 would be 1 upon e, and here you can write minus 1 upon 3 ln e. So we can write this minus 1 upon 3e. Therefore the coordinates of M point would be 1 upon cube root of E, comma, minus 1 upon 3E. So this is the solution of A part. Now we will proceed for B part here. In B part, we have to find the area of this shaded region. For that, first we have to find the coordinates of this point, the value of x. So we will write 0 equals to x cube ln x, again x cube equals to 0 and ln x equals to 0. X equals to 0 we cannot consider because out of domain. So we will be taking here x equals to e raised to the power 0, which is 1. So now we got here the value of x equals to 1. Now we need to find the area of the shaded region. So we will have to integrate between the limit 1 by 2 to 1. So area of shaded region will equals to integration 1 by 2 and here 1, and we have the function x cube ln x dx. Another thing, since entire shaded region is below the x-axis, so we will be writing here minus sign. Now we will integrate this. As we have x power 3 into ln x, so we apply the integration by parts. So here ln x into x power 4 upon 4 the limits would be 1 here and 1 by 2 minus integration ln x derivative would be 1 upon x into x power 4 upon 4 dx. Again ln x into x power 4 upon 4 limit here is 1, here is 1 upon 2 minus, now here 1 by 4 we will keep it outside and this x and x power 4 will cancel, so x cube, and further we will do the integration, then again it would be x power 4 upon 4 here and the limit here is 1 and here is 1 by 2 minus, now when you substitute the limits here, or further you can also write like this ln x into x power 4 upon 4 minus x power 4 upon 16, and the limits would be 1 and 1 by 2 minus, now we will substitute the limit. So when you substitute the limit 1 here, then ln 1 into 1 upon 4 minus 1 by 16. Now we will substitute the lower limit, then minus ln 1 upon 2 into here 1 upon 2 when you substitute, then 2 to the power 4 would be 16 and 16 into 4 would be 64. So you will be getting here 1 upon 64 minus minus plus, then again here you will be getting here this is 2 and 1 upon 2 when you write here it would be 1 upon 16, so that would be 1 upon 256. Now minus your this entire term will become 0, so you will be getting here minus 1 upon 16 plus 1 upon 256, and now here you can write plus 1 upon 64 ln 2. So we will be getting here minus, here you can multiply 16 in numerator and denominator, so this would be 16 minus 1, so this would be 15 here upon 256, and this would be negative plus 1 upon 64 ln 2. Now when we open bracket we will change the sign, so 15 upon 256 minus 1 upon 64 ln 2. So this is the solution of the given problem. I hope you understood this solution. Please like, share and subscribe this channel.